Good day, everyone. Today we're going to be talking about piecewise functions, basically part two. We're going to be going through a couple more problems to hopefully get our mindsets correct and kind of get the idea correct on this concept, dealing with some similar problems with a few differences to them and going from there. Okay. In today's two problems, we're going to do number 10, A and B. And then we also have on this other page, we're going to talk about number 16 here as well. Okay. Those are going to be the problems we go through, we talk about, we work out. And then hopefully after today, we're feeling pretty confident about these functions in general. So once again, to kind of go through our process solving this out, we talked about this in class yesterday about how to actually work through and to get these values together. In each of these problems, what I'm going to do is focus on my restriction point, or basically where is my values going to be split. Well, if you notice in this first one, we have x is less than 0 on the top and x is greater than 0 on the bottom. That should tell us right off the bat that 0 is going to be our fence, okay? Where I'm going to have an equation to the left and an equation to the right. Now, at the same time, I want to know which side each equation is going to go on. Well, this value here is telling me x is less than 0, okay? Which basically tells me I want all the negative values. Well, if you notice, on the left side of my fence, going from 0, -1, -2, -3, those are all my negative values. So what I can do here is I can basically state that this side of the graph, this left side, is going to be x plus 2, which means that the right side of the graph has to be 2x minus 1. Okay. At this point, now that I know this information, let's just use the values given to us. Okay. Oops. Sorry about that. Each one is definitely going to start at 0, okay? Notice how 0 is the fenced-in point. So what I'm going to do is I'm going to build two different charts. I'm going to build the first chart, x, y, and I'm going to start it at 0. And then since this one's going left, I want all my negative numbers, -1 and -2. For the other value, the 2x minus 1, same thing. We're going to start at 0. And then we're on the right-hand side, so I want all the positive numbers. So I'll go +1, +2. And at this point, I'm just going to plug those values into the equation. So for x plus 2, if I plug 0 in, that's going to be 2. If I plug -1 in, I'm going to get an answer of 1. And if I plug -2 in, I get an answer of 0. So I'm given the three coordinates 0, 2, which I'm going to put an open circle there because it's a not equal to inequality. -1, 1, so we got -1, 1, and -2, 0, creating our first line segment like this. Now I'm going to do the same thing with the other problem. We have 0, 1, and 2. If I plug 0 into the 2x minus 1, I get -1. If I plug 1 into 2x minus 1, I get 1. If I plug 2 into 2x minus 1, I'd get 3. So we go to 0, -1. This one's going to be a closed circle because the 0 value. At 1, 1, we have a coordinate. And at 2, 3, we also have a coordinate. Once again, we connect the dots and we get our second graph. So once again, the whole purpose of the problem is that we're literally just graphing half of each line. The one on the left is x plus 2. The one on the right is 2x minus 1. Let's go ahead and follow the same process for the second problem, okay? Because there's a slight difference in this one that we kind of want to understand. For this one, we have 2x minus 1 if x is less than 1, x minus 2 if x is greater than 1. So right off the bat, we see that our restriction is 1. So I'm going to come over here and do my fence at 1. Now from there, I have to determine which one is each side on. Well, we have -2, -2x plus 2. That is less than 1, which is all the values lower than 0. So I know that it's going to go on this side, okay, because it's all less than 1 there. Okay, that's all of my negative values, or even 0 would work for that one. For the other one, it is x minus 2 when x is greater than 1. So this one over here is going to be x minus 2. Okay, all the values that are bigger than 1. So now I'm going to follow the same process, create a chart for each one. And I'm always going to start at where I fenced in at. Well, this fence starts at 1, so this graph's going to start at 1. And then since I want everything lower than 1, I'm going to just keep going backwards, 0, then -1. In the other problem, we're going to start at 1. And then since I want all the numbers bigger than 1, we're going to start counting up, 1, 2, and 3. From there, we're just going to plug these in and get our coordinates. If I were to plug 1 into this equation up here, the -2x plus 2, this would end up being -2 plus 2, which is 0. If I were to plug 0 in, I would get 2. If I were to plug -1 in, I would get 4. The key thing to remember, though, is now for this problem, I have 2 greater than and less than inequalities, but neither of them are equal to at all. So when I work this problem out, the key thing you want to understand is that we're not going to have a closed circle anymore. They're just going to be 2 open circles on our fence. So at 1, 0, I have an open circle. Oops, let me change the color of that. Open circle. Let's just get that out of there. There we go. Open circle. At 0, 2, I have a full point. And at -1, 4, I have another coordinate. Okay. Ooh, excuse me. Made a mistake on this one. Our first coordinate was 1, 0. It should be right there. Then I should have this coordinate here and then this coordinate here. Let's get a line that looks like this. So my first graph is done. Now let's work on the second one. We have x minus 2. Now for this problem, once again, we're on the right side, so we're going to start at 1. If I were to plug 1 in for x, we would get 1 minus 2, which is -1. So at 1, -1, I should have another open circle. If I were to plug 2 in for x, we get 0. So I'm going to put my coordinate at 2, 0. If we plug 3 in for x, we get +1. Graph that out, and we get the graph shown. Notice once again how all that dotted line does is kind of break it up into 2 different graphs. Okay, that's kind of the key thing for these problems that you want to try to understand, in the fact that if I really want to get these graphs, if I really want to try to think like, what is this actually doing? Well, there's a piece of each graph. We have the graph that's in blue to the right here, and we have the graph in green that's to the left here. Okay, but they are broken up by that fenced line. Okay, and that's the key thing to remember. We draw that fence because it's going to restrict. Basically, one graph's can be on the left side of it, one graph's can be on the right side of it. The last problem we're going to talk about for today is going to be this evaluating a piecewise function, which we basically want to evaluate something algebraically. So in number 16 here, there is no graphing whatsoever. I actually want to know what the answer would be if I plugged in a 2, a 0, or a 4. So let's start with 16 if we had x equals -2. The whole idea of this problem is try to think, where could I fit this in at? Where would it actually work with? Well, if I would look at all of these values provided, we want to try to think, where does x minus 2 fit? Well, in this first one, we have -4x if x is less than -2, right? Well, we want to think, does -2 fit into this restriction provided? Okay, does -2 fit into this restriction? Well, that restriction is telling me x has to be less than -2. And even though they're equal to each other, technically it still doesn't work because it's not less than -2, right? It is -2, but it's not less than it. So this first one doesn't work. I can't plug x into that problem. Okay? So we got to continue on then. So I go to my next restriction. So in the next restriction, we have if x, or if -2, if x is greater than -2, or if x is less than 4. Okay, so I either have to be greater than or equal to -2, or I have to be less than 4. Well, since -2 would fit into that segment because -2 can equal -2, this is the line that -2 works with. So that just means I'm going to take 3x plus 2 and plug the 2 in for the x. this would become 3 times negative 2 plus 2. Or in other words, that would become negative 6 plus 2, which equals negative 4. And that's the answer for the first one. So notice all I'm really trying to do for these problems is try to think, where does my actual value fit? Okay. For the next one, let's talk about 0. We have x equals 0. So now, same thing, I got to try to think, where is this value going to fit? Well, if I go down the line here, the first one, once again, x has to be less than negative 2. That one's not going to work. In the middle one, we have x has to be in between negative 2 and 4. Well, 0 is in between negative 2 and 4, right? So this one works. So I'm going to use the same equation, 3x plus 2. I'm going to plug 0 in. This becomes 3 times 0 plus 2, which comes out to be an answer of 2. And that's the process of these problems. All we're really focusing on is, where does this number actually fit? Really, the equations I care nothing about until I actually plug a number into it. I really just care about my restrictions. Where does the x actually fit in it? The last one we would see here is 4. So I got to think, where could I actually plug a 4 in for my restrictions? Well, the first one we've already talked about a lot, which x has to be less than negative 2. So that one doesn't work. The middle one's close, but notice how it has to be less than 4, but it can't equal 4. Okay, technically 4 is not less than 4. So the middle one doesn't work, which basically means in the last one it has to work. And if we look at our inequality, x has to be greater than or equal to 4. So this one does work. So if I was using the 4 value, I would just plug 4 in. If x equals 4, I'd use the bottom equation, x plus 4, plug that value in to get 4 plus 4 equals 8 as my final answer. Go ahead and answer the final question on the Edpuzzle. Once you do that, that's it for the video. And I will see you in class tomorrow when we talk about this more in depth. Thanks for watching and have a great day.